Hi Prof, I'm Yu Shen. So today me and my partner Wen Yang from the group Fly Me to the Moon will be presenting you our idea for the lunar challenge. So basically we come up with a product design called Moon Spyder. Before we know more about the Moon Spyder, I will talk about our problem statement first. So as we all know, the exploration of lunar terrain such as steep cliffs, deep craters, caves, or volcanoes are usually descending in altitude, and most of them are inaccessible to rovers. And besides that, the size, weight, and movement pattern of Moon rover also make it harder to maneuver through all those terrains. And then the last thing will be the safety concerns for human exploration due to the uncertainties. With all those problem statements, we finally come up with our solution, which is the Moon Spyder. And here's the image of it. So the Moon Spyder is actually a mini 6-leg robot with a cable attached to the rover, which acts like an anchor. The robot will be deployed down into the exploration site while the cable controlling its descent. The cable can also increase the stability and descending angle of it by providing a support to it. This can prevent the robot topples off due to unbalanced position while moving through steep surface. On the other hand, cable can also use to reel the robot back in case of malfunction or low battery. The robot itself can also be equipped with camera or sensors onto it to suit various exploration missions. So for the working procedure, first of all, spiders are being pre-installed into the Moon rover. And then Moon rover is being parked close to the site of exploration. Spyder is then deployed from the rover onto the ground of the Moon, and they will start exploring while recording through a small camera. Lastly, when the mission completes, Spyder will be pulled back to the rover in order to save time and energy. So we have also done 3D modeling using SolidWorks, and now we'll share our model design and look more details into it. Yeah, so as you can see here, there are 6 2° of freedom legs in total, and each of them can rotate horizontally and vertically. Okay, so besides the cable attached onto it also have the capability to rotate 360 degrees to ensure that it won't tangle throughout the exploration mission. For the materials part, we will choose CFRP, which stands for carbon fiber reinforced polymers, to achieve a higher strength to it. For the cable part, we will choose alloy steel for it. Yeah. So now we will show an animation of the Moon Spyder. Yeah, so this is basically how a robot will move. So each time the robot moves a step, 3 legs will remain still and the other 3 will lift up and move forward. This can ensure that the robot will remain stable while exploring the lunar surfaces. Okay, so now I'll pass my time to Wen Yang for him to talk more about our ideas.
All right, thank you, Yushen. My name is Liu Yang. Okay, so there are a few assumptions and conditions in order for the Moon Spyder to work as intended. Firstly, the terrains explored mustn't be an upward slope that is too steep. The Moon Spyder is designed under the assumption that it progresses forward across a rough surface which gradually steeps or no slope at all. However, the Moon Spyder already has a lower center of gravity compared to the original bulky Moon rover, so it can already move upwards a steeper slope without losing its balance. Secondly, we assume the Moon Spyder is made of durable material. It will not break and fall apart easily, even after falling or sliding down craters. Lastly, we assume the cable connecting the Moon Spyder to the Moon rover is of sufficient length, which means the Moon Spyder will move forward until its battery runs flat. There will not be any problems where the Moon rover reaches its maximum, even if it slides down a crater or a hole. Here, we can look at the limitations of the Moon Spyder. Firstly, it is solely for exploration purposes only. It will not be taking any sample like dust and soil on the moon, as it is not equipped with any kind of robot arm. This is to ensure the size of the moon spider is kept at its minimal. And the other limitation is the moon spider is unable to explore areas or caves smaller than the robot itself. But actually, the moon spider can already explore caves which are relatively small due to its mini size. The moon spider only uses the built-in camera to record everything it can see as it progresses forward. Our design has a few advantages compared to the original concept of moon rover. Firstly, the moon spider is small sized. Having a smaller size enables it to explore underground caves, which is impossible for the bulky original moon rover. Other than that, it consumes lesser energy due to its smaller weight and size. Secondly, our moon spider is able to explore deep craters with high slopes. With the usage of cables, the moon spider does not need to maneuver back to the original landing spot on its own. So it does not have to worry too much even if it falls down a steep slope and is unable to walk back up. This largely increases the area of exploration possible. And that is the end of our presentation of the moon spider. Thank you.